We start with a point x1, y1 and a point x2, y2 on some straight line, and then we draw a point that we'll label xy on the same line. We construct what I call a fundamental triangle with legs parallel to the coordinate axes, and implicitly the x-axis is in this direction, the y-axis is in this direction, and the x-axis and the origin might be miles away from here, and the x-axis and the y-axis nowhere near the board. Doesn't matter. Okay, so we have x1, y1, x2, y2, and xy. We draw the triangle based on x1, y1, x2, y2. The rise of this triangle is y2 minus y1, and apologies, I started to write out the expression for the slope. I moved this down to where it would make a little more sense. The run is x2 minus x1, change in the x coordinate, change in the y coordinate, so that the slope is y2 minus y1 over x2 minus x1, slope being the rise divided by the run. Now I draw another triangle, and I could draw it either from x2, y2 or from x1, y1, but I'm going to use one of these points with the xy point. So I'm going to use this point, x1, y1, just because this is going to give us a result that's consistent with the way a certain formula is usually written. So now I've got a triangle here, and what do I have? I got a rise that's y minus y1, and a run that's x minus x1. Okay. Now, what's the slope of this triangle? Well, the slope of this triangle is rise divided by run, which is not y2, but y minus y1 divided by x minus x1. xy, if xy is on the line, then the slope from here to here has to equal the slope from here to here, has to equal the slope from here to here. So if we have a straight line, this slope has to equal this slope. Now I pause to write out a little bit of stuff here just to save a little time. You don't need to watch me write. What we're saying then is that if xy is on the same line that goes through x1, y1, and x2, y2, then both of these slopes are equal. Now, without looking at what I've written here, you should probably pause and write out just exactly what that means. What is equal to what? Well, hopefully you've done that, and you see that what I mean is that this slope, which is here, is equal to this slope, which is here. Now, the color coding is not essential, but it can be helpful, so I'll kind of circle that with a blue circle to match the color I used up here. Circle this with a white circle which matches what I have here. If we rearrange this equation, you should stop and do this. We easily get this. Now, this is a picture you should be able to draw anytime you need to figure out the equation of a straight line through 2 points. There's another common situation when we want to find the equation of a straight line through a given point with a given slope. To find that equation, well, we proceed in a way very similar to that we used over here. You should stop and do the common sense thing that you think would follow from what you've seen over here. Steps will be a little different, but the picture is going to be very similar, except it'll only have one triangle. So see what happens. Hopefully you've done that. Well, we get the triangle here with rise y minus y1 and run x minus x1. So the slope is y minus y1 over x minus x1. What are we going to do with that? Again, you should pause and think and see if you can anticipate the next step. Well, the slope is y minus y1, the slope is m. So okay, y minus y1 over x minus x1 is one expression for the slope. M is another expression for the same slope, so they have to be equal. Call this the slope equals slope formula for the equation of a straight line through a point with given slope. And this would be a slope equals slope formula for a straight line through two given points. We could easily solve this equation for y, and you should do that, or actually, to put it in the usual form for y minus y1. You should stop and do that. But clearly what we get, we multiply through by x minus x1, we get y minus y1 equals m times x minus x1. This is called the point slope form. This is called the 2-point form of the equation of a straight line. I don't recommend memorizing these as formulas unless you understand how to derive them. Actually, if you can't understand how to derive them from these pictures, then you probably ought to just memorize them because you're going to use them. But if we want to have a deeper understanding, we have to know where the equations come from and how they're derived. There are other ways of deriving the same equations, but this way derives the equation without really addressing the meaning of what it means to have the equation of a straight line. Here we have a very clear geometric connection to these equations. The insights that come from this geometrical understanding can lead us to the solution of deeper problems, wider-ranging set of problems than just the ability to use the formulas, although the use of the formulas is also quite important. The full logical statement of this situation here, our first situation where we have the 2 points, is that the point xy lies on the line through x1, y1, and x2, y2 if and only if y minus y1 over x minus x1 equals y2 minus y1 over x2 minus x1. Our argument here assumes that xy is on the line, so we assume the first part of this statement and concludes that y minus y1 over x minus x1 equals y2 minus y1 over x2 minus x1. So we've proven that if this is so, then this is so. We have not proven that if this is so, then this is so. So we haven't proven this if. So we haven't yet proven the if part, but we have proven the other part, which is the only if part. And you might want to review exactly what it means for one statement to be true if and only if some other statement is true. We've proven the only if. We've proven if this, then this. We haven't, we've proven if this, then this. We haven't proven if this, then this, and that would be the if part of this if and only if. That can be confusing. It's worth sorting out. You would do well to write down the if and only if statement for this case, where we have point x1, y1, and the slope m, and conclude that y minus y1 equals m times x minus x1.